In this short video, we are going to look at convex lenses and some of the properties of them, thinking about how we go and draw our diagrams. So the first one, right, a convex lens is one that goes and bends out. When we're going and we're drawing this, we have a line going straight through the middle. That is called the line of action because it shows where our light is being bent. So if we were going to go and work out where the focal point was, we'd start off using 3 beams of light. Making sure that we're drawing arrows on them to show the direction of the light, and the point at which those 3 beams of light go and intercept or go and cross over each other is our focal point. So on this particular diagram, that position just there would be our focal point and would be roughly 30 millimeters away from that line of action. So that is how we're going and we're working out where that focal point is. On a normal diagram, once we've got this, we would go and call that the F1, right? All the F1 means is the focal point. And the focal point will be the same distance from the line of action on both sides. So if we now go and look at how we go and draw our diagram, we start off with, or most questions will start off with something like this. It will tell you that it is a convex lens, and it will show you where the image is. Right, that image will have a certain height. It will also go and have the focal point already written on. So if we were going to go and draw a diagram here, so this is our object, and we want to work out where on this side we'll go and find the image. So to start off with, we are going to draw one straight line going from that point, and then that will go down through that focal point. Right, when you're drawing it, make sure it carries straight on through. Right, your second line is going to go from the object through that central point, and we can already start to see where that image should go and form. And the third point is going to go from the object down through the focal point on that side until it gets to the line of action. Right, if this was a question, then it would be on graph paper. So then that goes and draws a straight line going that way. So we can see that our image is going to form at that point there, where they all go and cross over. So that's one example. We want to go and do a second example. We might have our image, actual object even, maybe at that point there. So we want to go and work out, right, where the image is going to form. So same again. Straight line to the line of action, then down through that focal point. Second line going straight through the central point where that line of action goes and meets. The third one going through the focal point on the side of the object, then going through in a straight line there. So if that's our object, that would be our image. So from this, we can go and work out if there's been any magnification. So if we look here, our object is roughly 20 millimeters tall. Our image on this side is roughly 25. So to work out what the magnification is, we'll do image size 25 divided by actual size, which will be 20, which would go and give us what the magnification was. Right, we can also see that those lines that are going down there have almost flipped the other way up. Therefore, the image on a convex lens is always going to go and look upside down. So they are just some key points to think about when going and drawing diagrams using convex lenses.